Bismillahirrahmanirrahim. The manometer, which is an application on atmospheric pressure, like a U-shaped tube. He look like a U-shaped tube. It is used to measure the pressure of enclosed gas, or it is used to find the pressure difference between enclosed gas inside a container and atmospheric pressure. If we look to this apparatus, we find that it is a U-shaped tube, has two openings. One is free end and the other is linked to the gas which we want to discover its pressure. There are competition between both of them, between the pressure of the gas and between atmospheric pressure. If the gas pressure was more than the pressure of air, the liquid goes up in the free end. If the BA was greater than the pressure of the gas will go up in the other end, which is linked to the gas. And by using this small apparatus, by using this idea, we can find the pressure of the gas. Now let's discuss how can we find the pressure of the gas by using this small idea. Letter A. If the gas pressure is more than the air pressure, so the liquid will fall down near to the gas reservoir and rises up in the free end, and the difference between the two levels is called H. If we consider the 2 points, point A and the point B, the pressure at point A equal to the pressure at point B. Pressure at point A represents the pressure of the gas. Pressure at point B represents the pressure of air plus the pressure resulting from the liquid column, which is rho GH. In this case, we substitute by pressure of air by 1.013 times 10 power 5 Pascal plus rho GH of the gas, and the measuring unit will be Pascal or Newton per meter square. If it was a mercuric manometer, if the liquid was mercury, only mercury, the pressure of gas equal BA, which is atmospheric pressure, 76 centimeter mercury, plus the height in the reservoir, and the measuring unit will be centimeter mercury. So we have two cases or two measuring units. The first one Pascal, but we use the normal atmospheric pressure plus rho GH, or centimeter mercury, and in this case we should use centimeter mercury minus H, in this case, in the case of mercury only. This in case of mercury only. B. If the gas pressure is less than air, so the pressure of air pressing and the liquid rises up in the other end. It looked like the other, but the difference in the sign only. If you consider the point A and the point B, pressure and A equal pressure and B have the same horizontal level. Pressure of A equal pressure of gas plus rho GH, while the other side is BA. Let's move rho GH in the opposite side, so we are going to find that the pressure of gas equal BA, which is atmospheric pressure, minus rho GH Pascal. And then the pressure will be negative rho GH because the pressure of air is greater than the pressure of the gas. So it is negative. Pressure of gas in case of mercury manometer only. In the case of the mercury manometer only, the pressure of gas is going to be A minus H. And the measuring unit will be centimeter mercury, and if you want to find the delta pressure, it's going to be negative H. So we have two cases. Maybe the gas pressure is greater than, so it's going to be A plus rho GH or H in case of mercury manometer. If the pressure of the gas is less than the air pressure, so the pressure will be BA minus rho GH, okay, or negative H, or BA minus H. Let's discuss other one. If the gas pressure is equal to the air pressure, so the pushing force in the two columns are equal. So there is no difference in the liquid higher. So the pressure of the gas equal PA and delta pressure equals 0. So the gas, in the case of the gas, has the same pressure of air. There is no rises up in any of the two ends, and the delta pressure equal 0. Let's discuss some problems, and we discovered them. Number 1, he said that a mercury manometer is used to measure the pressure of gas in a reservoir in the mercury level if the free end is higher than the other by 36. What is the pressure of the gas in centimeter mercury and in Newton meter? Bismillah ar-Rahman ar-Rahim. The first one is too easy. Pressure of gas equal BA plus H, which equal 76 BA plus 36, so it will be 1012 centimeter mercury. We can change it from centimeter mercury to Newton meter square by many methods. By using cross multiplication, by putting BA 1.013 times 10 power 5 Pascal plus rho GH and substitute by the density of the liquid. Many methods. Here I choose a method which is finding the pressure in atmosphere. 112 divided by 76 centimeter mercury give you that the pressure of the gas is approximately equal 1.474 atmosphere. Multiplying by the pressure of gas, BA, normal BA, going to be 149316.2 Newton meter square. This is a method, and you have many methods also to change from centimeter mercury into Newton meter square. Another one which is tricky problem. He said that the distance between P and C is 13.6 centimeter, and he said that in the opposite figure if the atmospheric pressure in this place is 75 centimeter mercury. This place is the atmospheric pressure, not 76, it is 75. So I have at first, before we start this problem, to calculate the pressure of air in this area. How? By using the method of changing. I'm going to change it from centimeter mercury to Pascal. We know that 76 centimeter mercury equal 1.013 times 10 power 5 Pascal. So 75 equals what? By making cross multiplication, we discover that the pressure of air at this area is this number, which is smaller than what we used to use. Then this becomes a normal problem here. Pressure of gas equal BA plus rho GH, because the free end is higher. BA, which we calculated here in this case, plus rho 1000, G 9.8, H 0.13 and 6. By using a calculator, the pressure in this the gas is 101,300 Newton per meter square. In this problem, the tricky part was in the pressure of air is not 76 centimeter mercury, it is only 75 centimeter mercury. The other one, which is opposite to the other, here if we look, we find that the free end is lower than the end which is linked to the gas by 10 centimeter, and it is also water manometer. Though the problem here is not plus minus, the pressure of gas is less than the pressure of air. So if I want to find the pressure of gas, I'm going to set BA minus rho GH, BA minus rho GH, because the pressure of gas is less than the atmospheric pressure. BA is constant, 1.013 times 10 power 5 Pascal, minus rho 1000, H 0.1 with gravity 9.8. We discovered that the pressure of gas equal 100,320 Newton per meter square. Second part, he wants to find the delta pressure. Delta pressure means negative rho GH, the difference between the pressure in the gas and the pressure of air, which is 1000 times 9.8 times 0.1, and we discovered that delta pressure equal 9,800 Newton meter square. Try to solve some problems about manometer, and it is not too much problems. Try to solve it, and we are going to discuss any problem with me. Send it to me on WhatsApp. Thank you for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.